So today, I'm going to talk a little bit about chapter 2. I'm going to be working with uh, chapter 2 talks about descriptive statistics. And in descriptive statistics, um, we're going to be working with quantitative data. So those are some words we picked up from chapter 1, descriptive statistics and quantitative data. And remember, quantitative data, we're going to do some math on it. So in 2.1, we're going to start with the frequency distribution and their graphs. And so the first example we're going to look at is we're going to be given this data. So the data set is going to be pulse rates of all students. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12 and 12. That would be 24 pieces of data. So there's 24 data entries in this example. So what we're going to do is we're going to use this data set, and we're also going to use 6 classes. And we're going to do that to start with is we're going to construct an expanded frequency distribution table. An expanded frequency distribution, it's going to have a column for class, it's going to have a column for frequency, and then to be expanded, it's going to also have the midpoint, and this is going to stand for relative frequency, and this is going to stand for cumulative frequency. So we're going to have to complete all of those columns as we move forward. Now, the 6 classes, remember, basically, classes have to be between 5 and 20. Too few classes, you can't do a whole lot of inferring from the data. If there's too many classes, then there's too much to kind of sort through. So the sweet spot, as they say, is between 5 and 20 classes. So when you create a frequency distribution, the classes should always be between 5 and 20. That's an important number. And our example, they give us 6 classes. So to move forward, we're going to work on this first column, which is the classes. This is probably one of the harder things to deal with. So when it comes to classes, the first thing we have to do is we have to find what's called the class width. So it's going to be the maximum data entry minus the minimum data entry divided by the number of classes. Okay. Now, one of the things you could do in MyLabMath is if you want to try to do this a little bit more organized, one way is you actually can use pencil and paper and copy down these pieces of data. If you're more technology driven, I have what's called a snippet here. I can snip this, and I'll go and create a new one. And using the snip tool or whatever tool you have, you can highlight this, take a picture of it if you will, or however it works. And then I can copy this in one of the places I can copy it on mine is this is a Word document. So my Word document, I'm going to place that right here. And then I'm going to resize it. I think it's okay where it's located. Didn't really need to move it. So I'm going to just kind of minimize this a little bit, kind of shrink it, grab this corner, and I want to try to move that back again. I didn't want that up there. There you go. So I can make that a little bit smaller. I can kind of resize it, move it around a little bit. Okay, so I've done that. For me though, to continue with my teaching, I need to create that as a PDF file because I like the tools as a PDF file better. So I'm going to save this, and I'm going to save this somewhere, and I'm going to save this as a PDF file instead of a Word document. So there's a lot of little things in computers that you can do. I've already got this file name, so I'm going to rename it. No, I'm just going to copy over it, replace it. Okay, so I've got that going on there. All righty. So now I have a new document here, a new PDF file. And the first thing I want to do is I want to create these classes. So to do this, it was easier for me, instead of scrolling up and down, is just move the data down here where it could be more organized. Again, you can use paper, pencil if you want to, whatever is going to be best for you. All right, let me choose the color of my pen. I think I like this purplish color, be fine. So the first thing I'm required to do is I'm required to find this minimum value or this maximum value, then subtract the minimum value. So looking at my data entries, the maximum value in the first row, I see a 105. In the second row, I see this 120. So 120 looks like the biggest value. So to determine the class width, we also need to subtract the minimum value. So on the top row, I see the 68. On the bottom row, I see a 65. I don't see anything smaller than 65. So that's my minimum data entry. The number of classes was given to us, that was 6. So to determine the class width, we now can do that math using a calculator if you like. So I have 120, take away 65. That gives me this 55 on the top. And I still got to divide that by 6. So if I divide that by 6, I'm getting like 9.1666, bunch of that. Now, when it's decimal, what they ask us to do is round up to the next integer. So if it's 9.1, they want us to go ahead and round up to 10. If the answer was an integer, we would also want to round up to the next integer. So if we actually got 9, they would still want us to round up to 10 for our classes. So we always, whatever we get here in our maximum minus our minimum divided by number of classes, there's typically this rounding up 1. So keep that in mind as you develop your class width. So my class width is 10. Now the next thing is we have to create our lower class limits. Now the way we identify our lower class limits is we first have to identify the minimum value. And then we want to add that class width to complete the rest of the lower class limits. So the minimum value, as we noticed, was this 65. And what we want to do is we want to add the class width, which is this 10. And that's going to create then so we're going to add 10 to create the next lower class limit. So we're going to kind of do something like that. So I'll go ahead and go up to my table up here. I'm starting to get some information. So my classes, my lower class limit, the first one is the lower, we just started the minimum value, which is 65. To get my next class limits, what I do is I add the class width to that. So notice how I got that 75 down there. We add the 75 here. And we just keep adding 10 until we have 6 classes. So I have 85, 95. We have then 105. And we have 115. So that's 1, 2, 3, 4, 5, 6 classes. So those are my lower class limits. So I'm kind of building my classes as I go along. So I would have 75 and then 85, so forth and so on. So it kind of starts that. The upper class limits in a frequency distribution, the upper class limit needs to be 1 less than the next class limit. And then what we're going to do is we're going to use the class width to complete the rest of the upper class limits. So what we're looking at here is, notice that to create the upper limit here, it's got to be 1 less than the next lower limit. Since the next lower limit is 75, my next upper limit has to be 74. It's got to be 1 less. They can't actually touch. So we have the 74. And then once you get the first upper limit, we can use the class width to create the rest of the upper class limits. So 74 plus 10 would be 84. And notice how that's 1 less than 85. 84 plus 10 would be 94, which is again 1 less than the 95. So it's working out just fine for us by just adding the class width. So that's going to be 104. And again, you can use a calculator if you need to. And this is going to be 114. And then this is going to be 124. So I have completed my first column, which is the classes. The next thing we're required to do is we're required to find the frequency. The frequency is the hardest thing to do because there's so many pieces of data. So what I'm going to do is I'm going to use tally marks and I'm going to count how many data entries are in each class. So again, you can write your data on what I would do on paper is make sure your data is in pen, and then you can use a pencil to use tally marks. I'm going to use technology here and see if I can make this work for me. So I'll go ahead and scroll up here to this other piece, and I think I can kind of make things work here. So I'm going to use a color. Let me choose a color here. What color do I want? Let's just keep it this purplish stuff here. All right. So the first thing I want to try to do is identify data entries that are between 65 and 74. So 68 is between 65 and 74. 105 is not. 95 is not. 80 is not. 70 is. 70 is. 65 is good, as long as it's matches either the lower limit or upper limit, and or between. So that's the lower limit. We're okay there. 88, 90, no. 75, no. It's two. It starts on the next one. And I'm not seeing any other pieces. So what I'm seeing is 1, 2, 3, 4. So there's 4 data entries that are in that class. So that's called the frequency. So the data entries that are in this class are called the frequency. So the next thing I have is this 75 to 84. What you can do is clear these off or erase, and we can kind of begin new tally marks. And I also need to write down my 4. Okay. So I got a 4 here. So I'm going to pause the video, and I'm going to complete the rest of these. Okay, so I'll be back. So as we continue through the frequency, I came up with 7, 4, 5, 3, and 1 as the remaining numbers. Now, the frequencies, the sum of the frequencies, remember there's the sigma symbol. So the sigma f stands for the sum of the frequencies. That should add up to the sample size, or how many data entries we had. And we had, I think 24 entries was the sample size, the sampling of all the pulses there. Okay, so if we look at our numbers, make sure they add up to 24. 4 plus 7 is 11, plus 4 is 15, 20, 23, 24. So that does add up to 24. It's important that it does. If it doesn't, then you missed counting your tally marks. So there's all kinds of ways to try to count the frequency. You just have to figure out a way that may work for you. Okay. So you may even try to Google on YouTube, is there an easier way to count these frequencies? Because if there's a lot of data, it's challenging. So let's see what else we have going on here. So we did our frequencies. We've done that. Now ready to do our midpoint. To do the midpoint of each class, what you do is you have the lower class limit and you add it to the upper class limit and you divide that by 2. Once you do that, to find the remaining midpoints, just add the class width, which was that 10, and that will help you identify the remaining midpoints. So the lower class limit plus the upper class limit divided by 2 is going to be the midpoint. So for the first class, we have 65 and 74. So 65 is the lower class limit. The 74 was the upper class limit. So if we add those together and divide by 2, that will give us our midpoint. So 65 plus 74, that's going to be 139. If I divide that by 2, that's going to give me 69.5. So that's going to be the first midpoint, is 69.5. So again, to do that, you're going 65 plus the 74, and then you're dividing that by 2. And so that gave me 139 divided by 2, which was this 69.5. So from there, if we just add the class width, which was 10, and again, I can do that on a calculator or by hand, I'm going to get 79.5 as the next midpoint, 89.5. We have 99.5. And then we have 109.5. And then we have 119.5. So notice that the midpoint should be right smack in the middle of the class. So if you want to verify that, if you subtract the 74 minus the 65 and divide by 2, that should give you that number of 69.5. Or I'm sorry, that would give us, let's see here, 74 minus the 65 is our range. Let's see, if you divide that by 2, that will tell me how far apart they are. Divide by 2. I'm sorry. Divide by 2, 9 divided by 2 would be 4.5. So notice that the 4.5, that number there, if you subtract 4.5 from the midpoint, that would give you the lower class limit of 65. If you add the 4.5 to the midpoint, that would give you this upper class limit. So notice that if I find the range, which was 9, divide by 2, that would also tell me how far apart the lower class limit and the upper class limit are from the midpoint. We'll talk about more of that as we move forward. So let's move on to the relative frequency. Relative frequency. So we got our midpoint done. Relative frequency, what we do is we divide the frequency of each class by the sample size. So that's the number of data entries. So remember, the sample size was this 24. So remember, the sample size is also the sum of the frequencies. So this n is going to represent the sample size, and f is going to stand for the frequency. So to find relative frequency, the formula they use is basically f over n. So if I look at my table, this actually represents the n. So n is going to be the sample size, which is this 24 here. So if we divide f by n, that's going to give me what we call our relative frequency. So if we have 4 divided by 24, we end up with this decimal. In your MyLab math, it tells you to round to decimal places. I'm going to carry this out 5 decimal places and round it 4 decimal places. So I'm going to have 0.166666. And if I round that to 4 decimal places, this 6 would tell me to round the 4th place up 1. So it's going to be 0.1667. Now, if I want that as a percent, I can move the decimal 2 places to the right, and that could be 16.7% as a relative frequency. I think MyLab Math just wants it in a decimal form, so we would just leave it as 0.1667 if they want it rounded to 4 decimal places. I have 7 as the frequency. If I divide 7 by 24, I'm getting, again, if I round 4 decimal places, I have to go 5 decimal places to round 4 decimal places. So I have 0.29166. So if I want to round that to 4 decimal places, again, that 5th number tells me to round up the 4th number to a 7. So it's going to be 0.2917. So that's going to be my relative frequency. And again, if I move my decimal 2 places to the right, that would be 29.17%. So I'm going to pause the video and I'm going to complete the rest of the table, and then you can kind of compare your answers to mine. So as I move forward, again, since the frequency here was 4, that should be the same thing as this top class of the 65 through 74. So I shouldn't really have to do that math since it's the same. So again, I'm getting as a decimal 0.1667. And again, if I move the decimal 2 right places to the right, that would change it into a percent, which would be like 16.67%. So again, that tells you how much of the data is between 85 and 94. So the next slide, I got this frequency of 5. So the relative frequency would be 0.2083. The next one, the frequency was 3. So the relative frequency was 0.125. That actually, I didn't have to round it. That was an exact answer if I was rounding 4 places. So, I could put a 0 there if I needed to. Don't have to, though. And the last one, the frequency was 1, and the relative frequency would be, as a decimal, 0.0417. In other words, about 4% of the data is between 115 and 124 if I'm talking percentage math. But I think in my lab math, they just want that as a decimal. It's easier to understand, though, as I move forward if I change that into a percent notation. So that's our relative frequency, is you just divide the frequency by the sample size, the number of pieces of data. Cumulative frequency, what you do is you add the frequency to the previous cumulative frequency. So this kind of has a addition concept to it. So to do the cumulative frequency, the frequency is 4, but since there's no previous frequency, the cumulative frequency is 4. Now, since the frequency is 7, I have to add the previous cumulative frequency, which is the 4, and that would become an 11. The next frequency is a 4, but the previous cumulative frequency was 11, so my new cumulative frequency would be 15. My frequency is 5, and the previous cumulative frequency is 15. So I add those together, and that would be 20. That's going to be my cumulative frequency. They just keep adding up. So 3 to the 20 would be 23. And then the 1 to the 23 will give me 24. In cumulative frequency, it has to add up to the sum of frequencies, or n. It's got to be the sample size. So keep that in mind. You've done it right if your 24 matches up with the sample size or the summation of the frequencies altogether. So that completes how we do the frequency distribution.